The purpose of this video tutorial is to explain how input and output to an equation block in XtendSim works. So let's take a look at this simple model. So in this model, items are created. Each time an item is created, it gets a die roll associated with the first die. That is pushed into an attribute. This attribute is called first number. So that's pushed into an attribute associated with that item. We then go into an equation block where the desired behavior is to add the first die to the second die. So we have two dice. We're going to add the score together, and then we're going to determine a result based on the outcome of the die rolls. And that's going to be pushed into another attribute through a set block. Okay, so to start with, we already have our first attribute set up. Let's go ahead and take a look at how to set up the equation block to get the second die roll and then how to push the result out. So I've pre-coded the equation block, and we just have the simple equation where we add the two dice together, and then we get a certain score if the outcome's over 35, and then we get a different outcome if the score is less than 35. So the first thing we need to do is make sure that we have access to the information inside the first die and second die variables. Those are actually user-created variables, and those are both inputs into this equation block. So how the inputs get into the equation block is through the input table. In the input table, we have two types of inputs available. We have attribute and connectors. Now I see that there's a bunch of other stuff inside here that you can choose from. Most of that stuff is not going to ever apply to models that we're doing, and it's way beyond the scope of the course to talk about how we use database indices and the other things that you see here. So we're just going to talk about attributes and connectors. So an attribute, just to review a little bit of XtendSim, is a property associated with an item. So we have an incoming item. This is the green or item version of the equation block. We have an incoming item. It has attributes associated with it. So if we choose an attribute, we'll see here that it defaults to no attribute. So to choose an attribute, we can either choose a pre-existing attribute that we've already set up previously in the model, or we can choose to get a new value attribute. Again, string attributes can be used, but they don't work the way you think they do in the equation block. And database address attributes definitely don't work the way you think. So only use value attributes in the equation blocks unless you get to something more advanced, which this tutorial does not cover. So in this case, we already have the existing attribute for first number, which in the set block, we pushed into our items that we're passing through. So now first number is available as input into this model. Now you'll notice here, we actually have the word first die. So if we try to test this equation, it's going to tell us, hey, first die, I don't know what that is. The reason I'm getting that error is because I've not defined what that variable is inside the input list. And in this case, I thought I did, but I actually named it something different. So I'm going to have to name it first number so that it matches up what I have in the attributes. Either that or I have to go change the attribute to match. Okay, so now this means that the value first number in this equation is coming from the input to the model, and it's properly associated. Now we'll notice there's nothing here in the input table for this second die. So we need to add another line into the input table. We do that by clicking on the plus down here. So that plus down here, if we click on that, it says resize, copy, or delete. we can just resize. Now, when we resize, notice that this is the total number of rows, not the number of increased rows. So we need a total number of rows of 2. And now we see that there's a blank value unpopulated here. Now, the second one, for illustrative purposes, we're going to get from a connector. So we need to change from an attribute down to connector, which is at the bottom, and it'll have a default value or label of incon 0. You can certainly use that if you want to, but it's good programming practice to give your variables meaningful names. If you just use incon 0, incon 1, etc., it's going to make your code very hard to understand with or without comments. At any rate, whatever we use for this variable name, we have to use the same name down in the code. So we have a choice of using incon 0 in the code, or we can change this to second die. This is going to cause an input connector to appear on the side of our equation block that we can then hook up. On the Options tab, if we click Show Input Connector Labels and Output Connector Labels, that can be really helpful, especially if we have multiple inputs and outputs coming from the equation block. Makes it much easier to troubleshoot and ensure that things are getting hooked up in the correct order on both, or the matching order on both the inside and the outside of your equation. Okay, so now we don't quite have ourselves ready, because on the output side, we would like the output to be this outcome. And we have to set that up inside the output table. So the output table, again, it comes with a default, which is this outcon 0. So we want it definitely to be labeled outcome. But then we need to decide whether we want to have that be an attribute or a value that's getting pushed out. In this case, I'm going to go ahead and just push it out into an attribute just for illustrative purposes. I could also choose that to be connector, similar to how it works on the input side. And now I have to choose the value of that output. Now it doesn't have an output. I could push first number back out, but I don't think I really want to change the value of first number. I might want to. So if I want to actually change first number, then I would change the output to be first number. In this code, it wouldn't actually do anything, because first number does not get changed by the code. So if I set it to first number, then first number would still continue to be whatever it is, because the code hasn't made any changes. So to get the outcome in there, I'm going to need to choose a new value attribute. When I set up an attribute, this is being used in the equation block as an actual variable. So you have to follow the same rules as you do for normal computer science variables, which is to say that you're not allowed to have any special characters except underscores, so you can't have spaces, and you also should not start anything with a number. So good programming practice, we're going to start with a letter, and we're just going to use camel case since we can't have any spaces. In this case, it's only one word, so there's no reason to use the camel case. Camel case, in case you don't know what that is, if you notice the way I capitalized both first number and second die, that's what we mean by camel case, because you're alternating lower and uppercase. Modal is actually not sensitive to case anyway, so using the camel case is just for your own clarity and human factors purposes. So naming this attribute outcome. Now notice that I need to name it whatever's being pushed. Whatever I think is being pushed out, I have to have that same name in the variable name, regardless of whether it's going to be an attribute or a connector. Now to find out if my equation is working correctly, I'm going to click the test equation button. I see nothing, and then that means it's working properly. If I did something incorrect, like let's say I spelled outcome incorrectly here, when I push test equation, it's going to say, hey, I don't know what that variable is, or whatever other error it might throw at you. This isn't a video on how to use Modal, which Modal, by the way, is the programming language that is being illustrated here, and that's what's inside the equation block and underlying extensim. Modal might look like C++, but it is, I would call it C++-ish. So its syntax is very similar to what you have in C++. It is not totally identical to C++. So pushing test equation, and now, okay, so now I have my equation. Now you'll notice here, I have now a connector that's sticking out of the bottom. And that's because it appeared in the input table as a connector. So if I added more connectors, I would see them sticking out of the bottom of my equation block. So I'm going to hook up the connector second die. And now I also see on my get item, like let's say I wanted to do something like plot the results, I could then pull the property that I just set up before, which is to say outcome. And now that outcome would be available to plot somewhere else if I wish to do so.